Hi, today we're going to talk about Postgres-XL. We're going to talk about what it is as a developer or a solution architect, when you should use this and when you should not use this.
ख्वाब हो तुम या कोई हकीकत कौन हो तुम बतलाओ.
If you look at databases, Postgres has a very, very long history. In fact, during the 1970s or even before, in the late 60s, databases were invented. IBM started something known as IMS, or Information Management System, and there was a researcher at IBM known as Cod, right, Edgar Cod, and he wrote a paper talking about relational databases and how you could have databases and the structure on relation of databases. Before this, there were a couple of other models that were proposed, but this was revolutionary at that point of time. Surprisingly, it was overlooked by a lot of people, and it wasn't picked up by IBM initially. The first people to start making money off of it and start using it commercially were other companies. If you look at, so this is where the history of Postgres really starts. So there is somebody known as Michael Stonebreaker, who's a really huge figure in, if you look at database as a field, and he started this company known as Ingress, right? Ingress started off in the early 70s. They had their product come out in the late 70s. He was also with the University of Berkeley at that point of time, and there was also a commercial, there was also an academic version of this database and a commercial version later on. So this database is so old, which means, so Postgres has a long history in relational databases, is one of the databases that has spawned several databases, which means that Postgres or Ingress basically is the basis of Microsoft SQL at one point of time, Sybase, and a lot of other databases basically, right? So Postgres has a rich history as a database. So it's an awesome database if you want to start a project. It's got almost all the features that you would need and you would want from a relational database, and the code base has obviously matured and grown and been in production, and it's a very good database to begin with, right? Now, what is Postgres-XL? Okay, so when you look at the problems that you start to have with big data, right? And big data means that you have a huge amount of data. Okay, we're not talking about GBs, we're talking in the range of hundreds of GBs and terabytes of data, or probably petabytes of data. I'm not sure if petabyte is something that you can handle with this product, but we're talking about a lot of data, right? If you have a huge amount of data, or if you have a huge amount of requests coming in that you want to service, okay, that's when you want to look at Postgres-XL. For everything else, Postgres is an awesome tool. There are lots of ways and lots of steps where even if you're using a single Postgres instance, you can increase it, and you can take several steps where you can give it multiple disks by using a RAID array. You can do lots of creative things and vertically scale this database to serve a lot of requests, right? There's a lot of creative things that you can do where you can do writes from a particular node and reads from other nodes and things like that. So for obvious reasons, I'm not going to go into those kinds of setups. One of the things to look at is, big data has got not only, a potential to save lots of amount of data, but there's got like this huge ecosystem of databases and the combinations that you can use. So like the Hadoop ecosystem has got tens or scores of tools that you can use together to form different kinds of combinations, right? So this ecosystem's got lots of different tools that you'll want to use for your particular use case. Now, what is the use case where Postgres-XL shines? Okay, so when you want to use the capability of full SQL, which means that you want all the properties of SQL, you want to have your queries formed in any way, in any form or fashion, you want to use full SQL capabilities. You also want the transactional capabilities of SQL, which means that you want to have full ACID capabilities, which means that your transactions will either get executed or not get executed, right, in a binary fashion, and you don't have inconsistency within your data. So if you want like the full power of SQL that a relational database provides, but at the same time you have other kinds of problems, okay, this is the other kinds of problems that actually push you towards Postgres-XL. So if you want relational database and if you want the power and the expression of SQL, just use Postgres, right? So this is like, you know, when you try to learn karate, the first thing that they teach you in karate or any martial art is basically, we'll teach you how to fight, but your main purpose is that you should try to avoid fighting as the first strategy. You should not fight. That's the first strategy. So when you learn about Postgres-XL, you should not want to use Postgres-XL. That should be your first strategy. But if your use case is that there is no other way, you need this, then you can use it, right? So with that aside, and in fact that's the use case where you don't want to use it. In fact, if you don't have the specialized team, if you don't have a couple of Linux administrator or one good Linux administrator who can get this sorted and get this straight and get this set up nicely, then look at another product that will just, you know, get set up and you don't have to worry about it. So this is not something, this is a high maintenance product, right? So this is the first disclaimer that I'll put up. Okay, with that out of the way, let's get into the core of what the use cases are for this product. The first couple of things that you want to use this for, or the first main bifurcations and the main ways of using this database is, one is when you want to have your data saved in multiple machines. Okay, so the first use case is where you can save your data in one particular machine. You don't expect your data to go beyond that one single machine, but the number of requests that you want to serve, the throughput of the requests that you want to serve is so enormous that you are sure that you will not be able to serve it from this one single machine, or you want to be able to scale to multiple machines in the future. So this is the single use case, or this is the first use case where you know that your data is going to be able to happily live in a single machine. So that's probably in the range of, you know, a few hundred gigabytes or up to a terabyte. If you're using a really large machine like a 32 GB or a 64 GB or a 128 GB machine, you're safe with that sort of a setup. You're using nice hard drives, probably SSDs. Then you're okay with a replicated setup. So that's the first setup where you know your data is not going to cross a certain limit, but the number of requests may be huge. Then, and you still need a relational database, right? Then you fit the first Postgres scenario, Postgres-XL scenario. The second setup is the kind of setup that is normally solved by sharding a database. So in this case, what you know is that you have a large amount of data that you probably will not be able to fit into a single node. Even if it's a large node, or even if you want to have small nodes, you want to have a large cluster of nodes. So maybe 3 nodes or 4 nodes, or you know, increase these nodes as you go along. This is the second setup where you want to shard your tables, but you don't want to take the headache of managing all of these shards manually, where if you look up even sharding, on a cursory glance, you will see that it's a headache. You have to create these tables that are named differently. You have to create these views that are in front of them, and then you have to be able to call them in a union, or when you load your data, you need to load them load it in a certain way. So it is a sort of a headache, and that's the reason of the existence of this product. So this is the second use case, where you have a single table, but that table is so large that it probably will not fit in a single machine. So you want to be able to have it split into multiple machines. So, and this is not exclusive in the sense that, the first use case is not exclusive, which means that you have one table which you want to be able to replicate, and the second table which you want to be able to distribute amongst all the other machines. These are not separate different use cases that you definitely need to be on one side or the other. You can mix and match, right? So with that being said, the second use case basically is that you have a single table which is expected to be, or is currently so large that it needs to be distributed amongst several machines. So this is when the beauty of MPP comes in, where you can have your data of a single table reside in multiple machines, use the power of Postgres-XL and do the computation and divide your computation across multiple machines and get your answers for that queries that you're trying to run. So this is basically using, on the data node level or on the lowest level where the computation actually happens, using a shared nothing architecture, getting your answers back and using the power of MPP, right? So which is massive parallel processing. So you can have multiple machines that are doing your processing in parallel. So earlier you were stuck with one single machine, the memory and the CPU and the IO of that one particular machine, and then you had to rely on increasing that. Now you can distribute your workload amongst several smaller machines. The reason for this is also economic, which means that if you try to buy more and more and bigger machines, it gets more and more expensive. But when you start looking at smaller machines, it is much more cheaper, which means that if you cumulatively add, or if you add a total of all the processor and the memory that you have on 10 machines, and if you look at the cost of that, and if you look at the cost of one single machine that would hold the same amount of processing power and the same amount of memory and the bandwidth on the hard drive, you will quickly notice that the single machine is much more expensive, whereas the smaller machines are cheaper to assemble, right? With that being said, this is the second use case, where a single database spans across several machines. Now, why you want to use this and why this product is useful and what it actually does is that you can run Postgres-XL on those multiple machines. When you try to interact with it, you don't have to worry about figuring out where a particular record lives, on what machine that record lives. So when your application interacts with this database, you can still just treat it like a normal PostgreSQL machine and just make queries to it, and Postgres-XL will figure out where your data lives, how to distribute this query, how to divide this, where to run the remaining queries, where to run the all computations inside of your data, inside of your nodes. It will figure out the answer, it will give you the response. So from the application side, you don't need to worry about what's going to happen and what kind of queries and where the data lives. So that is a layer of abstraction that you get. When you try to save the data, you don't need to figure out where you're going to save this data. Once you've installed the application will figure out on what node the data will live at. So this is the abstraction, and this is the main benefit that this basically database gives you, right? So two things we figured out. The first thing is we figured out that if you want to be able to scale horizontally, and if you want to be able to save your data or the same data on multiple machines, right, and be able to query it and get lots of throughput, which means be able to service lots of requests and be able to scale those requests horizontally, you want full SQL, then that's your first use case. If you want the second use case, where you don't want to take the headache of sharding your tables, dividing your tables into multiple nodes and saving them on multiple tables in multiple machines, then you want Postgres-XL, where your data will live in lots of different nodes, and you will still be able to query it as if it was in a single node. So that is your second use case. You can combine these, where if you know that a particular table, which is for example your dimension table, will live and will only span a few MBs, because for example you're running let's say car manufacturing unit, where you know that you have particular models of cars that are only of a certain size, which means that you're never going to exceed a certain limit on that. You know that your table is going to remain only up to a certain limit. You can have that as a replicated table, which means that whenever a query is run, that table will be available locally, so that to fetch that data, you don't need to go to another machine, you don't need to go over the network to fetch that data. You can have your fact tables which are normally if you're trying to design a warehouse, a data warehouse, you'll have a lot of data inside of these fact tables. So you can have your dimensions replicated, you can have your fact tables sharded if you're trying to build a data warehouse. And this product is very, with all the complications and with all the high maintenance that you get out of the way, this product is really versatile in the sense that when you're trying to look at trying to be able to service not only like a data warehouse scenario, but also you're trying to service like an OLAP OLTP scenario, where you're going to have your front-end application which is actually accessed by hundreds of users, and you still want to be able to service all of these in below second frequencies, which means even in requests need to be served in hundreds of milliseconds or below hundreds of milliseconds. You can very comfortably do this with Postgres-XL. Obviously your architecture will be very different based on the kind of setup you're trying to achieve, but you can do an OLAP style, you can also do an OLTP style with Postgres-XL. So it's very versatile in that way. It is a little complicated to set up and to maintain, but once you get that out of the way, it serves both the needs. Where if you have been with, or if you've researched big data and databases in general, you will see that there is a quite wide gap between both of these worlds, where if a certain type of product does OLTP really nicely, you will not expect it to do OLAP and data warehouse style queries. But if it does quick queries, you will not expect it to do really large massive computations. It spans both the worlds. Obviously it doesn't mean that you're going to use this single database or a single cluster for both the purposes, which means that if you start to do things like that, where if you have reporting queries and transactional queries at the same time, you're going to be in a soup. Why? Because if you try to mix your transactional queries, now inherently transactional queries, or the queries that are supporting your web application or your mobile application, they need to be really fast, which means that users are expecting things to go really fast, or at least they're expecting things to be consistent, which means that you'll want to meet a certain SLA type, which means that if one query takes 100 milliseconds, most of the queries should be in that range. You should not have one query which takes 10 seconds and another query that takes 100 milliseconds between requests, because your application will then start becoming very, very unreliable. That you don't want. So that part is where you want to have a clean bifurcation, whether you're going to do OLTP on this or whether you're going to do OLAP style queries. Because let's say, for example, if you are going to use this cluster that you've set up for 5 machines, and you're going to give access to this for let's say a mobile application and a web application which is doing pure OLTP, and you're going to open this up to some business users who are going to run OLAP style queries and who are going to run analytical heavy queries that do a lot of data processing. Now you have to remember, even if you have like 5, 7, 10 nodes, all of these resources are not infinite. We have a finite amount of CPU, of IO, and of memory. Now this memory, if somebody is going to run like a huge query on this, which is going to take, let's say, a few minutes or a few hours, right? And at the same time, you have processing happening from the other side. These resources are limited, and there will be resource contention, which means that, if your hard drive is the bottleneck from, let's say, that large analytical query, is going to definitely impact the other side, which means that all the requests from the mobile application and the web application that are going to come in, those are going to be so much slower. So never make the mistake of mixing these two kinds of workloads. This product is flexible, versatile, but you want to keep your analytical and your transactional queries separate. So you probably want to make 2 clusters, or you want to divide your databases so that particular nodes will only service a particular type of query. So your resource allocation needs to be very clean if you want to be able to maintain certain SLAs on any site. So this is a very high level overview of what Postgres-XL is, what it does as a product. We are not going to go down into details because there are close to around 4 or 5 components that basically comprise this database when you look at deep down specifics. So I think this should be covered as part of the next video, which will be part 2. Hope this has been of use to you, and let's talk in the next video.